let's proceed with the quadratic equation, or the second degree polynomial equation. So, okay, getting from the previous, the introduction of this module, the second part, so we were able to understand this one. Okay, so we have three coefficients. Okay, three coefficients, and if we know these coefficients, we can construct a quadratic equation. Okay, so given at least three data points, okay, so we can construct quadratic equation. Okay, so if you notice the recurrent system, we have A3, which is the point equation, P1, the linear equation, and if we added another P, then we will have the quadratic equation. Okay, so if we add more, then it will be more or higher degree polynomial equation. So, but we know and we understand quadratic equations, we try to understand it first. Okay, so we have the reverse part. So coefficients of Pn are determined by forcing the polynomial function pass through each data. So recall this one. Okay, so where we have n is equal to 2 for quadratic equation. So the first data point, we assign a0 for the first y, and then we have y1 for this. We're just following this formula from the previous one, and then okay. So I think you can recall this one from the general step we have discussed. So the solution is this one. Okay, so we assign a0 as the y of 0, a1 as the delta y1. So we think of this as the slope of the line. Okay, and if we're dealing with quadratic, so a2 can be solved using this formula. Okay, so you see delta y1 is actually a1. Okay, but we need to get delta y2, which is by this formula. So basically, if we try to understand this one graphically, we have this xy. Okay, it's quite clear here, and then we have 2 points. Okay, first point, so we assign y0 for a0, and then if you have the second point, so you get a0 and then a1, and if you have the third point here, so you will get a2 first by the difference of, by the idea that you get the delta y1, and then also this one here. So we have here delta y2. So meaning we are looking for the slope of delta y1 and delta y2 in order to get a2. Okay, so okay, going back, so we can determine a0, a1, and a2. Okay, so recall a2 can be solved using the difference of the slopes of y1 and then y2. So y2 is between the slope between the first and the third point. Okay, and then this one here, the first and the second points, the slope in the first and second points. Then you can get a2. Okay, so from the drawing, you can construct then an equation or a slope of the line after that. Okay, so you have the quadratic equation or quadratic function. So then there's an example here. Determine the quadratic function that has the points 0, 1, 1, 5, and 2, 3. So we have the first point here, 0, 1. So therefore 0 to be the y0, the first point. Okay, and then we have a1, it's the slope between point 1 and the first point and the second point. So that's why 5 minus 1. Okay, and then 1 minus 0. have here 4. And for delta y2, in order to get a2, so the slope between the first and the third points, so we have 1. So then we can solve for a2, which is this one is 1. So the slope between the first and third, this one is the slope between the first and second. Then we just follow this one, then we get negative 3. So we have a0, 1, a1, 4, a2, 3. So using the function coefs, we can get the coefficients numerically. Okay, so given the 3 points here, x data and y data, so we can get the coefficients. Okay, this is correct. This is the same as what we solve manually. And then given the coefficients, we can determine the coefficient quadratic equation or quadratic function. So given a0, a1, and a2, if we try to understand this or analyze this equation or simplify this equation, we have simplifying this one, and we get this quadratic equation. Okay. Now our goal for interpolation is to predict. So using the a coefficients and also the x data, we can predict any y given x. We can predict y given any x. Now our x here, we as an example, so from negative 1 to 3 with an interval of 0.25 or the step 0.25. Okay. So using our previous function Ebal-Foley and coefficients derived from t here, okay, and then the x data. Lastly, we have the desired x we want to predict. Okay, so then we have the word predict here. Okay, so here we have the predictions of respective x. Now to understand this graphically, you can plot actually. You can see that we have the 3 points given. Then you can construct a line, okay, given from negative 1 to 3. And actually, you can, no need for a line, you can actually create the succeeding points. Okay, so these are the points. Okay, prediction, for example, at negative 1, we have somewhere negative 9